All right, Algebra 2, this is the lesson I have been waiting all year to teach you guys. It's the unit circle. Trig is my favorite unit of study in Algebra 2. Algebra 2 is my favorite class to teach, and I'm so bummed we don't get to do it in person. But here we go. We're going to make the most of it. If you haven't already, you want to print out this unit circle if at all possible. So if you haven't done that, hit pause, go print it, come back, because it's going to be so much easier if it's already drawn for you and you're filling in the blanks. It is worth going through and actually writing it out because you will need to know this unit circle. If we were in class, I would give you unit circle quizzes. If you're going on to pre-calc, you will definitely need to know the unit circle. So what is the unit circle? It is taking all of those angle measurements in the coordinate plane and connecting them, looking at the main degree measures that you will see in the coordinate plane. So what do I mean by that? Well, here you can see we've got the origin right here. And we've got a circle. Remember, a circle is equidistant from its center point at all pieces. Why do we call it the unit circle? We call it the unit circle because the radius is 1 unit. So let's just go and go around and mark in the degree measures that we know. These are the degree measures that are the most common, that help us the most in our study of trig. We know that this one right here, if we don't go anywhere, it will be 0 degrees. Now, if we go all the way up top, we know that that one is 90 degrees. So, because we have a right angle right there. So the quadrant 1 goes from 0 to 90 degrees. That should feel really familiar. Through quadrant 2, we go 90 to 180. Another 90 degrees takes us through quadrant 3, and we're down here at 270. And another 90 degrees brings us back up. One full revolution around the unit circle would be 360 degrees. Now let's just take a look at some of these markings. Look in quadrant 1 here. These are the most common spots for angles of rotation. Look, if we look here and here, do you see how that divides quadrant 1 into thirds? So 90 divided by 3 is 30 degrees. So this angle right here, this one right here, is 30 degrees. That's a very common angle measure to deal with in trig. Another third, I'm just going to add 30 degrees. 30 plus 30 is 60. 60 plus 30 is 90. And then you can see those thirds marching all the way around the unit circle. To find their degree measure, I'm just going to add 30 degrees each time. So 90 plus 30 is 120. 120 plus 30, we're skipping this halfway in between. We're going to come back for those halfway marks, but those are not thirds. So 120 plus 30 is 150. 150 plus 30 is 180. 180 plus 30 is 210. If you don't like adding 30, put your finger over that 0 and add 3, and then put the 0 back. 18 plus 3 is 21, put the 0 on. So 21 plus 3 is 24, put the 0 on. That would be 240. 240 plus 30 is 270, plus 30 is 300, plus 30 is 330, plus 30 is 360. Hey, we're all the way around the unit circle. That is awesome. Just add 30. It's the basic skip counting from elementary school. Now, look at the halfway mark. We've got some halfway marks. There are a couple ways you can think about this. If you take halfway between 0 and 90, well, that's 45. Or you can think what's halfway in between 30 and 60. That's also 45. So now we're just going to skip count by 45s. 0 plus 45 is 45, plus 45 is 90. Plus 45 right in the middle is 135. Notice that's also halfway in between 120 and 150. Plus 45 gets us to 180. Plus 45 gets us to 225. Notice also halfway in between these two, or 15 degrees, because halfway between a difference of 30 would be 15. Plus 45 to 270. Plus 45, or think what's halfway between 300 and 330. That's 315. Ladies and gentlemen, we have now gone all the way around the unit circle with our degree measures. You now know a third of the unit circle. It's just those multiples of 30 and multiples of 45 degrees. Isn't that fantastic? There's another set of blanks in here. That's for radian measure. We are not going to worry about radian measure until next week. We will fill it in though. So we'll get there. But we're going to go now to the outer edge here, these ordered pairs. How in the world can we figure out what those ordered pairs are? Well, to begin with, we need to remember that we had a radius of 1. So the radius of the circle is 1. That puts us out here at this point. Trying to decide what color to make that. 1, 0. The x-coordinate is 1. We did not go up and down because we're in the coordinate plane. So 1, 0. Up here at the top, x-coordinate is 0, but I went up 1. So we've got 0, 1. Over here at 180, we would be going to the left, back 1. But not up or down at all. So negative 1, 0. And then at 270, x-coordinate is 0, and the y-coordinate is negative 1. So far, have we done anything that is remarkably difficult? I hope not. We've just looked at some degree measures and some obvious ordered pairs. Now, these other ordered pairs are not quite as obvious, but we're going to be able to find them out fairly simply using those special right triangles that we took a while at the beginning to review. Notice those were 30, 60, 90 triangles and 45, 45, 90 triangles. Look at the angle measures we're trying to find here. 30 degrees, 45 degrees, 60 degrees. We're going to use those special triangles. So you'll notice down here at the bottom, I've created to scale 2 triangles. Here is a 30, 60, 90 triangle. Now, notice that if I look right here at a 30 degrees, if I drop this down right there, there's my 90 degree angle. So this is 30 degrees. And this angle up here would be 60. And here's 90. What's the length of that hypotenuse? Well, that is the radius of the circle. That is 1. So this radius right here, that is length 1. Now I need to remember that relationship between the legs and the hypotenuse in a 30, 60, 90 triangle. And I know that the smallest leg is half of the hypotenuse. And so this length right here must be a half. And then if I take that smallest leg, if I want to find that other leg, this is my anchor leg, remember, because the hypotenuse is twice as much. If you take this smallest leg and multiply it by root 3, I'll get this length. So 1/2 times root 3, and we like to combine that, it is root 3 over 2. Now we know the lengths of those legs of the triangle. Why is that helpful? Well, I have a piece, I cut it out. You can actually cut yours out as well. It helps to see this, I'm going to take it here. Notice I've got my 1, my 1/2, and my √3/2. I put the measurements inside so it could come along with me. Notice that triangle is right there. There's my 30-degree angle. Now, my ordered pair will be my x-coordinate here. That's going to be √3/2. And then my y-coordinate is this smaller leg length, 1/2. Look at there. I now know the ordered pair of that point is √3/2, 1/2. But that's not all I know. I've got other quadrants. If I take this triangle and I reflect it over here, I scribbled on the back so you could see it on the white. I now have the same triangle over here at this 150-degree mark. And so my x-coordinate is still this longer leg, which is √3/2. And my y-coordinate is this smaller leg, which is 1/2. But now note that we're in the second quadrant. Well, every ordered pair in the second quadrant, the x-coordinate is negative and the y-coordinate is positive. So I've got the same ordered pair here because I was using the same triangle, because this is a 30-degree angle and 30 degrees is the reference angle, the angle to the horizontal for 150 degrees. I just need to make the x-coordinate negative. Well, I can still keep using this triangle. Flip it down. Same side lengths, same ordered pair. √3/2 is the x-coordinate. 1/2 is the y-coordinate, but now we're in quadrant 3. Well, everything in quadrant 3, both coordinates are negative. So this would be negative √3/2 and negative 1/2. That would be the ordered pair for 210 degrees. The same ordered pair, just the signs are different. And I can flip it over here. Again, still with a reference angle of 30 degrees. All 4 of these angles have the same reference angle. They are 30 degrees away from the horizontal. And because they have the same reference angle, their ordered pair will be the same. But in quadrant 4, the x-coordinate's positive and the y-coordinate's negative. So the ordered pair is √3/2, negative 1/2. Look at that. 4 ordered pairs for the price of 1. But it doesn't stop there. This triangle also is 60 degrees. Look at that. If I just rotate it, the same side lengths. So I'm not even having to learn new numbers. I'm still dealing with √3/2 and 1/2. Now the x-coordinate is 1/2 and the y-coordinate is √3/2. Same values, but the ordered pair is swapped, almost like an inverse. Now, I'll flip this over here at 120 degrees. Notice they have the same height. Both of these ordered pairs are at the same height, and so the y-coordinates would be the same. And the x-coordinates are the same, but in quadrant 2, that x-coordinate is negative. And we'll flip this down to the bottom here. Same ordered pair, but both coordinates are negative. And then quadrant 4 at 300 degrees, also 1/2, negative √3/2. And so now we almost have all of the ordered pairs filled in for the unit circle. They're either 1s and 0s or negatives, or √3/2 and 1/2, except for we have 4 left. Those 45-degree angle markings. So we need to go back and look at a reference triangle that is a 45, 45, 90, whose hypotenuse, let's see if I can put this in here. The hypotenuse is still 1 because we're on the unit circle. So the hypotenuse is still 1. It's going to be a 1 there. Well, I know in a 45, 45, 90 triangle that if I take a leg and multiply by root 2, I get the hypotenuse. So I'm going to go backwards and I'm going to divide by root 2. Now that is the value, 1 divided by root 2. But in all, historically, mathematicians have not liked those radicals staying in the denominator. So if we rationalize it by multiplying by root 2 over 2, root 2 over root 2, I end up with root 2 over 2. And that is the form that is most well known. So that's what we're going to use, the side lengths of root 2 over 2. So here we are. The x and the y coordinate are the same. They are both root 2 over 2. And we can take this triangle and reflect it over here at 135. This also has a reference angle here of 45 degrees. So it will have the same ordered pair, but in quadrant 2, the x-coordinate is negative and the y-coordinate is positive. So negative root 2 over 2, root 2 over 2. And in quadrant 3, flipping that down, those side lengths are the same. Both of them are negative here in quadrant 3. And finally, our last one. Here we have root 2 over 2, negative root 2 over 2. And now we have all of the ordered pairs of the unit circle with all of the degree measures. And there are lots of patterns. Really, you only have to know 1s and 0s, root 3 over 2s, 1/2, and root 2 over 2. If you know quadrant 1, you will have the same ordered pairs in each of the quadrants. The only difference is some are negative, some are positive, according to which quadrant. All right? So that is the unit circle. You want to actually practice putting that together. But why would we do that? That's the big question, right? What in the world is that going to do for us? Well, let's suppose, I'm going to try my whiteboard here. Keep that unit circle handy. Let's suppose I would like to know what the sine of 60 degrees is. All right? Well, let's go to 60 degrees and think about this triangle right there, 60 degrees. I know that the sine is opposite over hypotenuse, right? So this opposite side is root 3 over 2. But what's the hypotenuse? The hypotenuse is 1. And so anytime you're going over 1, it's just this opposite side, which happens to be the y-coordinate. So the sine of 60 degrees is actually just the y-coordinate, root 3 over 2. Well, what about the cosine of 60 degrees? Well, the cosine is the adjacent side over the hypotenuse. The adjacent side here is that 1/2. But the hypotenuse is still 1. So it's just that x-coordinate. Here is the brilliant piece about the unit circle. And that is the reason we look at these coordinates is because they tell us the sine and the cosine. The x-coordinate is the cosine of your angle. And the y-coordinate is the sine. Now, how are we going to remember that? If we were in class, this would be a little more entertaining. But I have a way that I remember that the cosine is x and the sine is y. And you have to say these things correctly. And so here it goes. It's the cosine is x. Cosine's x. It's closed mouth, and cos is kind of like x. So the cosine's x. And then you've got the sine is y. It's like really with a big, it's kind of operatic. And the sine, it's kind of like your sign. So you open your mouth really wide and you go, sine is y. So if you can remember those, and you're probably laughing and rolling your eyes at me right now, but you'll remember it, hopefully. Cosine's x and sine is y. And then you'll be able to use the unit circle. So let's give it a try. Can you tell me what the cosine of 210 degrees is? Well, take your finger and your unit circle and find 210 degrees. Oh, 210 degrees. And I asked for the cosine of 210 degrees. Well, cosine's x. What's the x coordinate? Negative root 3 over 2. That is the cosine of 210 degrees. Let's find the sine of 300 degrees. Well, take your finger, find 300 degrees. There it is. And the sine of that, the sine is y. So the y-coordinate's negative root 3 over 2. So the sine of 300 degrees is negative root 3 over 2. Now, all we have to do is figure out what the tangent is. Well, the tangent is opposite over adjacent. Let's see if I can find my triangle here. If I want to find the tangent of 30 degrees, tangent of 30 degrees, that's the opposite. Opposite's 1/2. Over the adjacent. Well, the adjacent's root 3 over 2. Notice that is the x coordinate. I'm sorry, the y coordinate. I just lied there. The y coordinate over the x coordinate. And we know that the y, that's the sine of 30 degrees. And the x coordinate is the cosine. So this is another way to define tangent, and that is the tangent of an angle is the sine over the cosine. This is called a reciprocal definition of tangent, and that is the y-coordinate over the cosine. Notice y over x, that's like slope. Well, we talk about the tangent line, the slope. Y over x, sine over cosine. So if I want to find the tangent of 30 degrees, 1/2 over root 3 over 2, the nice thing is those 2's cancel out. And the tangent is just 1 over root 3. Let's do one more. Tangent of, let's do 135 degrees. All right, grab your unit circle. Go to 135 degrees. The tangent is the sine over the cosine. So the sine is the y-coordinate here, root 2 over 2. Over the cosine, the x-coordinate, negative root 2 over 2. Well, any number over itself is 1, and one of them was negative. So the tangent of 135 is negative 1. So in tonight's homework, I'm going to ask you quite a few sine, cosine, tangent questions, but all of them will be on the unit circle. So you just need to keep your unit circle handy, put your finger down, look for those x and y coordinates. Remember, cosine's x, sine is y, and the tangent is sine over cosine. Good luck. I hope you enjoy it.